This is section 7.3, square root functions and inequalities. Our objective today is I can graph a square root function and square root inequality and state the domain and range. Now if we're looking at these key concepts, we want to pay special attention to the domain and special attention to the range, because those are the pieces of the key concept that we're really going to be focusing on. In example 1, they want us to identify the domain and range of f of x equals square root of x plus 4. Now I went ahead and posted what the domain and range of a square root function looks like over here so we can work with that. So we know that the domain only includes values for which the radicand is non-negative. So what we need to do, we need to take whatever's under the radicand, which in this case is x plus 4, and we need to make sure that we set it greater than or equal to 0, because we know that it cannot be negative, so it has to be bigger than 0. So then we're just going to go ahead and solve for x. So when we subtract 4 from both sides, we end up with x is greater than or equal to negative 4. And then all we're going to do is write the domain exactly how they would like us to write the domain. So we're going to say that given x, x is greater than or equal to negative 4. And that's going to be our domain. So now let's go ahead and talk about the range. We need to be able to find f of negative 4 to determine the lower limit of the range. So if we go ahead and do that, we're going to have f of negative 4 equals the square root of negative 4 plus 4. So when we go ahead and solve this out, we're going to have the square root of 0, which is just 0. So when we're writing the range, we want to write given f of x is greater than or equal to 0. In example 2, we're going to graph the function and state the domain and range. Now, based off of the key concept that they gave us, we know that this 2 and this 5 are going to play a critical role here. And we know that these values represent h and k. So our h value is going to be 2, and our k value is going to be 5. And we know that that's going to be the very minimum point of our graph. So now we have to make a table of values for x is greater than or equal to this 2, since this is our minimum point. So if we do that, we'll go ahead and just use 2, 3, 4, 5, 6, 7, and 8. This will give us a really good idea. We wouldn't have to use as many, but this will give us a really nice idea of what this graph looks like. So then to get the y values, we're just going to have to plug these in. So for example, we're going to have the square root of 2 minus 2 plus 5. So 2 minus 2 is 0, so we'll have the square root of 0 plus 5. The square root of 0 is just 0. 0 plus 5 is 5. So we do that for each of these. We'd end up getting 6, 6.4, 6.7, 7, 7.2, and 7.4. So when we go to graph these, we'll go ahead and go to 2, all the way up to 5. Now we'll go ahead and graph 3, 6. And now, let's see, we're going to graph 4 and 6.4. And 5, 6.7. And 6 up to 7. And 7 up to 7.2. And 8 up to 7.4. So this gives us a really good idea of what our graph looks like. So we can go ahead and draw through these points. And it does look like what it should look like. And we see that 2 is that minimum value. And it is going to be that same shape, that f of x equals x squared. But it's translated 2 units right and 5 units up. And we notice that as x increases, y increases. So then when we go to state the domain and range, we can say that given x is greater than or equal to 2 because those values are increasing only. And then when we're talking about the range, we can say given y is greater than or equal to 5. On example B, we're still going to graph and state the domain and range. Now, we know that the minimum domain value is at h, and in this case, h is -3. So we need to make a table of values for x is greater than or equal to -3. So when we go ahead and do that, we're going to have -3, -2, -1, 0, 1, 2. This ought to give us a pretty good idea of what this looks like. So then we're going to need to plug these values in. So it's going to look like this. We're going to have -2 square root of x. Well, we're replacing our x now. So instead of x, we're going to be plugging in that -3. So we're going to have -2 square root of -3 plus 3 minus 1. The square root of -3 plus 3 is going to be the square root of 0, and -2 times the square root of 0 is going to be 0, and 0 minus 1 is going to be -1. So you'll do that for each of these and get all of the different y values. And now we can go ahead and take a look at graphing this. So because a is negative, the graph is similar to f of x equals the square root of x, but it is reflected in the line f of x equals -1. Because the absolute value of a is greater than 1, the graph is vertically stretched. It is translated 3 units left and 1 unit down. So when we're talking about the domain, we know that given x is greater than or equal to -3. That's our lowest x value. And when we're talking about range, we know that given y is less than or equal to -1 because that's the behavior when we look at the y values. In example 3, they want us to graph a square root inequality. So because we already went over the graphing, I went ahead and graphed this one for you guys. And now we want to talk about what the domain looks like. We know that given x is greater than or equal to 4. And then because y is less than, the shaded region is going to be below the boundary and within the domain. So that means when we go to shade this, we're going to want to shade in this area here below and not past the domain. So all of this would be shaded in. So we can tell where to shade just by looking at this sign. Since y was less than, we shaded down. But now we can check and see if we shaded correctly. And the way we can do that is that we can select a point in the shaded region and see if it actually is a solution. So I'm just going to choose the point 7, negative 5. And if we plug that in, we're going to have negative 5 is less than the square root of 7 minus 4 minus 6. If I simplify that, I'll have negative 5 is less than the square root of 3 minus 6. And if I simplify that even further, I'm going to have negative 5 is less than negative 4.27, which is a true statement, so we know we shaded correctly.